Hello, this is Jack Jackson back with the second of our series of videos on descriptive statistics. So in this video, we're going to be talking about different types of data. It's important for us to know with what kinds of data we're dealing with so that we know how to work with that data. So statistics deals with data. That's a lot of what it's about. And so data can be classified by type, category, and level. Knowing the type, category, and level of data is important because knowing the nature of the data determines what type of statistical analysis can be used with it. So the most basic thing we can do is divide data into two types, qualitative and quantitative. Qualitative data is non-numerical in its basic essence. It has attributes, and it is also called categorical data or attribute data. It may actually have a number to it, but that number doesn't necessarily measure or count anything. So sometimes you have to be a little careful that even though if it may have a number, if the number serves as a label only, it doesn't have any kind of real meaning to it, then it's still qualitative data. Examples of qualitative data would be color, a model of something, a brand, a type of defect, etc. The other type of data is called quantitative data. Quantitative data has a numerical scale, so it's some sort of numerical data where the numbers actually have some meaning to them. Examples would be counts of things, time, temperature, mass, weight, length, lots of different things that you can measure. So qualitative and quantitative. So let's see if you can understand those basic definitions by going through and working this problem. So what I'm going to ask you to do in working through these videos is many times I'm going to present a problem or exercise for you to do, and I'm going to ask you to pause the video, work the problem yourself, and then on the next slide I will give you the answer to that so you can check your work as you go along. Now you can go through here and not pause the video and just watch my solutions, and if you want to do it that way, that's your prerogative, but I think that you will get much more out of the videos if you will do the things like I ask you to here, which is pause and work through and answer these yourself, because ultimately you get much more out of something when you actually do the work yourself. So even if it's done wrong, you'll learn something from your mistakes. So what I'm going to ask you to do that here is do that with this problem here. So I've got 8 different types of things that we might measure, and I want you to identify the type of data in each of the following. So you're going to identify it as either qualitative or quantitative. So press pause now. Okay, now you're back, so I assume that you've put an answer by each one of these. Let's take a look and see if you got these now. So the brand of toothpaste, that's qualitative. Okay, there's no real numbers involved with that. A type of defect, like a scratch or a dent, that's a qualitative data. But the number of defects is something that we can count. It has one defect, 2, 3, 4. That's quantitative data. The mass of a bearing is also quantitative. We're measuring it in maybe in grams or kilograms. A color of hair, that's qualitative. It could be a blonde or brunette or whatever. So that's qualitative data. The weight of a person, that's quantitative. There's a number involved with that. That might be in pounds or in newtons. Okay, the body temperature. Body temperature is quantitative. There's a number there. Degrees Fahrenheit, degrees Celsius. Shirt size, small, medium, large, extra large, that's actually qualitative. Now, I do have a couple of homework problems based on this material where one asks you to list these things and then actually take some do some problems of this type. Now, if you have quantitative data, we can further divide it into two types, discrete and continuous. Now, discrete data is finite or countably infinite. So finite means there's just so many things there. You can count them all, like there's 15. You can count 1, 2, 3 up to 15. Okay? And it stops. That's finite. Countably infinite is there's one for every natural number. 1, 2, 3, 4, 5, 6, 7. Even though it may go on forever, it's infinite, but it's what we call countably infinite. So that's discrete. So notice that the data comes in, you might say it comes in chunks or blocks of data. Okay? And so what happens is you have you have 1 and then you have 2. There's nothing in between. Okay? So from examples of that would be counts, the number of people with a certain blood type, the number of dots on the top faces of a pair of dice. A lot of things that are counting things are discrete. Okay? So lots of times we're dealing with discrete data. But sometimes we're also dealing with continuous data also. Continuous data is uncountably infinite. It includes an interval of the real numbers, like all numbers between say 0 and 10, including all possible decimal numbers. Okay, so they're not only they're infinitely many there, they're what we call uncountably infinite. Now, even though we may round off continuous data, if we were to measure it more precisely, we can attain more decimal places. So, for example, heights are continuous data. Now, you may, in the United States, we would round this off to probably feet and inches. So you might say, you know, you're 5 foot 8 inches tall. You're rounding it off to the nearest inch. Okay, but in reality, if we were to measure that closely, we could get closer and closer and closer and do more and more and more decimal places. So things like heights, weights, lengths, speeds, temperatures are all examples of continuous data. So let's see if you can do this now. Here's an exercise for you to do. Identify the category of quantitative data in each of the following. Hopefully each of these 8 things are actually quantitative data, and you're going to identify it as either being discrete or continuous. Once again, press pause now. All right, now that you're back, hopefully you have answers for all of these. Let's see how you did. The mass of a bearing is continuous. Okay, if you measured it closely enough, finer and finer and finer scale, then you get basically any positive number might be a possibility for a mass of a bearing. The number of boys in a class of 30, that's discrete. In fact, it's finite. It's somewhere between 0 and 30, and it's either 0, 1, 2, 3, 4, and so forth. There's no, you can't have half of a person, right, or anything like that. So it's discrete. If you were to count those up and add them in, you'd be taking an entire boy at a time, a chunk of data like that. Number 3, the number of die rolls until a 6 is obtained. That's also discrete. There's either it comes the first time, or the second time, or the third time, or the fourth time is that you get a 6. However, notice this does go on forever. There is no upper limit here. So this is an example of something that's it's countably infinite, but it's still discrete. Okay, or the number of defects in a set of parts. Okay, we're counting some whole number there. It's either 0 or 1 or 2 or so forth. So that's discrete. The weight of a person, that's continuous. If you had a fine enough scale, you could measure that closer and closer and closer. If you get all possible positive real numbers for a weight of a person. Well, at least up to some, there's probably some weight above which no one has ever obtained. Body temperature, that's continuous. The floor area of a house, continuous. Salaries of employees, that's actually discrete, because depending on your unit of monetary measurement, here in the United States we use dollars and cents. Everything's rounded off to the nearest cents. So when you give a salary, it's actually a discrete thing. Now, the next thing that we're going to look at are 4 levels of data in increasing order of information. The first 2 are basically qualitative levels, although ordinal is sort of like quantitative, but not really. And then interval and ratio, are the higher 2 are quantitative levels. Now, when I have these there's an order to them: nominal, ordinal, interval, ratio. And if you're trying to memorize the order, notice that the first letters, N-O-I-R, spell a word, noir. Now, let's talk about what each one of these means. Well, first of all, I'll talk about this basic idea. A nominal level has certain characteristics. An ordinal has all the characteristics of nominal and then more. Interval has all the characteristics of nominal and ordinal plus more. And ratio has all the characteristics of above plus more. So there's an increasing level here to the amount of information that is provided by the data, and an increasing amount of what you can do with it. So let's talk about the nominal data first. Sometimes this is also called categorical data or attribute data. It is nominal, means in name only. So that's basically what you have. You have names only. You put things in categories and you have the names of the categories, but that's all there is to it. So there's no inherent order, and mathematical operations don't really make sense. So some examples of nominal things would be color, manufacturer, flavor, etc. Ordinal data, on the other hand, has a little bit more. It still has categories, so it's like nominal data in that sense, but then it also has more. Those categories have an inherent order. Now, there's not necessarily any absolute numerical scale, so subtractions and divisions don't really make sense, but we do have an inherent order. So example is something called, there's a Likert type scale, which would include things like a scale that goes like strongly agree, agree, disagree, strongly disagree. That's a Likert type scale. You could have sizes: extra small, small, medium, large, extra large. There's an order there. Both of these things have order. Okay? Places: first place, second place, third place. But for example, just to say first place and second place doesn't tell you how much ahead the first place was of the second place. And second place and third place doesn't tell you. Tells you the person was second place was behind the first place and ahead of the third place, but it doesn't tell you how much. So there's no really absolute numerical scale with that. So there's order, categories, and order. If we go higher, though, interval have categories, order, but they also have scale to them. In this case, addition and subtraction make sense. Okay, but to contrast that with ratio, there's no natural zero, so multiplication and division don't make sense. And really, the only things I know of that are in interval data would be dates and temperatures. See, when you have a temperature of 0 is somewhat arbitrary. 0 in Fahrenheit, 0 degrees Fahrenheit, 0 degrees Celsius are two different temperatures. They don't mean zero energy, or zero heat energy, or zero vibration. So that it does make sense to say, for example, a temperature going from 10 degrees to 20 degrees is going up by 10 degrees. And going from 20 to 30 is also going up by the same amount. So additions and subtractions do make sense. But going from 10 to 20 is not necessarily doubling the temperature. That doesn't really make sense. So that's why temperatures are interval rather than ratio. Dates are the same way. Our calendar is kind of set on an arbitrary date. The calendar that most of us use in the world is based on a Christian calendar that someone in medieval times set where they thought the birth date of Christ was. And actually our dates don't even have a year 0. It's sort of a hypothetical. It goes from 1 BC to 1 1AD. Okay, so intervals are pretty much just dates and temperatures. Now, when we get to ratio data, that's the highest level. It has category, order, scale, and a natural zero. So here, when you see zero in ratio data, it means you don't have any of it. And most of our data, a lot of data is like that at least. It can be either discrete or continuous. So it could be counts, which is discrete, and zero means you don't have any of them. And 1 means, of course, you have 1, and 2 is 2. And it does make sense to add, subtract, multiply, and divide any of these data values. So counts of things are always ratio and discrete. Weights and heights are ratio but continuous. Okay. So for example, if you say someone is 3 feet tall and someone is 6 feet tall, the 6 feet tall person is literally twice as tall as the 3 foot tall person. It does make sense. Okay, now it's your turn to see if you understood this. So identify the level of data in each of the following. Let's review. The data is nominal, ordinal, interval, or ratio. So pick the appropriate one of those 4 things for these 9 things that we could be measuring. Okay, as usual, press pause now. Okay, now that we're back, let's see how you did on these problems here. All right, the mass of a bearing is the highest level. It's ratio. There's a natural zero. Not only do we have it's something we're actually measuring that has a number to it. It has an order to it. It has a natural zero. We can abstract, multiply, and divide those things. It makes sense. Everything makes sense there. So it's a ratio. The finish order in a race, first place, second place, third place, there's definitely an order there in a category, but we don't necessarily have, we can't really talk about how much further, we talk about how many places something was above another one, but we can't talk about how much farther it is above another one. So that's ordinal data. The number of boys in a class of 30, that's just a basic count. That is a ratio data. It has a natural zero. Zero means they don't have any. It has all the characteristics that we need for ratio data. Body temperature. Remember, temperature is interval data. It's one of the very few things that is interval data. The number of die rolls until a 6 is obtained, that's ratio. That's a count. Counts are always ratio data. The number of defects in a set of parts, again, that's a count, so that's ratio data. The weight of a person, that's going to be ratio. The year you're born, that's interval. Remember, we talked about dates or years especially as being intervals. Interval level data, that's the interval data really is just temperatures and years for the most part. And your age, though, however, is ratio. That's how long it's been since you were born. That's actually a continuous thing. We often round that off, but it is a continuous thing. All right, so here's another set of exercises here. And this has quite a few things on it. So you're definitely going to want to pause this and see if you can work through this, and then go back and finish it up. So first of all, let's do the questions in red. First, we're going to classify the type of data in each of the following measurements, but first thing we want to do is just list what types of data are there. The next question lists the categories of quantitative data. Okay, so for quantitative data, what are the categories there? So list those. And then finally, list the levels of data in increasing order. So see if you can, from memory, if you can list the types of data, list the categories of quantitative data, and list the levels in increasing order. Let's just do that much first, then we'll try to apply it to the specific things here. So press pause, come back when you finished that question. Okay, so we're supposed to do these 3 things. The two types of data are qualitative and quantitative. So it's either qualitative or quantitative. The categories would be either continuous or discrete. It's in one of those two categories. If it's quantitative data, it's either continuous or discrete. And the four levels of data in increasing order of information are nominal, ordinal, interval, ratio, in that order. So nominal has the least amount of information, categories only, whereas ratio has the most amount. So now what I want you to do is, in this question number 1, you've got exercises A through G here. Identify them as qualitative or quantitative. And then for 2, classify each of these as continuous or discrete. And then number 3, classify these as nominal, ordinal, interval, or ratio. You're definitely going to need to take a few minutes to work this. So press pause now. Okay, let's see how you did. Okay, the color of your automobile is qualitative. The brand of shoes you're wearing is qualitative. Your weight has a number to it. That's quantitative. Your height is quantitative. Your gender is qualitative. The number of defective items in some sample is quantitative. And the type of defects present is qualitative. Okay, now this next bunch in 2, we're supposed to classify them as the category is either continuous or discrete. Your weight is continuous, height is continuous. The number of defective items or the number of people with disease, those are both discrete. The time of day is actually continuous. Even though we may round it off, it is actually a continuous thing. Finally, in this third group, we're trying to identify the level as nominal, ordinal, interval, or ratio. The number of automobiles your family owns, that's the highest level, ratio. The color of your automobiles, that's the lowest level. That's just nominal. The year your auto was made is interval. The number of miles you have driven your car is ratio. And the birth position in your family, first child, second child, whatever, that's ordinal. So we have now in this video seen how to classify some data into different types by 2 types, qualitative or quantitative. If it's quantitative, we'd be able further divided that into 2 categories, continuous or discrete. And all data can be done in 4 levels, either nominal, ordinal, interval, or ratio. And knowing these 3 classifications tells us what kinds of things that we can do with that data.